So let's have a look at another aspect of triangle, similar triangle, and as well area of a triangle. A different part of the roof is in the shape of an isosceles triangle. By the way, what does isosceles triangle mean? It is a triangle that two sides out of three are the same length with base 14. So that's my base, and those are the two same. In this part of the roof, Michael, because this question was about Michael and he does build a house, makes an attic room by putting in the two vertical side walls AB and DC. So we can see this what is referring. There is a wall here and there is a wall here. So therefore that area, that's where I'm going to have the room. Shown in the diagram below, not to scale. The distance from B to C is 8, and we can see that. The total height of the roof is y meters, y. And AB and DC, so AB and DC, they are exactly the same. They equal in length, and the length is x. Okay. So what do we need to do? We need to use similar triangles to show that x is equal 3y over 7. Well, first of all, I need to understand what is similar triangle. So as the word is saying, the triangles are similar, meaning they are in some aspect the same, but in some aspects different. That's what makes things similar, isn't it? Okay. So when we are talking about any shape, a triangle, well, there is only two things we can talk about. We can talk about the length of the sides of a particular triangle, and then the other thing we can talk about is the angles inside, isn't it? That's all. That's how we can describe that. So when it comes to similar triangles, angles are the same exactly. However, sides are different. Now, they are not different, very different. They are in a specific ratio to each other. Now, what does that mean? Or not specific, the same ratio to each other. What does that mean? That means that I had a triangle, I blow it up, and then it became big triangle. Okay, it's the same triangle, it just expanded. That's mainly how we can look at that idea as well. Okay, so we need to use similar triangles to work out x 3y x equal 3y over 7. Where am I going to have those similar triangles here? Well, since I have x and I have y, I need to have a triangle that involve x and involve y. So I'm saying, well, I can identify those small triangle, isn't it? That's one. So I can identify that one. What do I know? So let's say AB. I know that this length is x. What about this length? Can I find? Well, yes, all of that is 14, but then the one in here is 8. So that means if out of 14 I cut out 8, I am left with how much? With 6. Very good. I am left with 6, and that 6 is equally divided between those two parts. So that means that will be 3 and that will be 3. So I know that this side is 3. I don't know this length. So I have a triangle with x. That's great, but I still need y involved. And then the other bigger triangle that I can see is this one here. I can see that that is the bigger triangle, and that's, we can see that this length here, that is my y, and this length here will be what? Half of 14. So that means that will be 7. Now, how do we build? Because the idea here is that we are using the fact that corresponding sides are in the same ratio to each other. What does the corresponding side mean? So I like to make things simple, not very complex. So I'm saying, well, in every triangle, I can say there is a short side. So that's the short here. That's the short here. Then there is like a really long side. Those are the really long one. And then this one is the middle length. So that's my middle. So corresponding side. As a short side in one triangle relates to the middle side, no point of using long one, I don't have it, then I'm saying it will be the same in the big triangle. As the short relates to the middle, right? So it has to make sense. Short to middle, short to middle. Now, I am going to have a post that talks about similar triangle. I'm going to attach it. Well, not to video, but to the post. Have a look at it. It has all possible ratios of similar triangle. Okay, so I have my equation built. How do I arrive at that? So when I have well, fraction equal fraction, there are two ways of so I can either cross multiply it, or in this case, where am I going with my calculation? I want to have x on its own, not x divided by 3. How do I get rid of that division? We multiply. If I multiply one side of the equation, I have to multiply the other side of the equation. How come will that get rid of that 3? Because 3 divided by 3 is 1, and 1 multiplied by x is x. Therefore, on the other side, we have y multiplied by 3, which is 3y, and over 7, and yes, we have what they were looking for. Okay, let's have a look at next part. The area of the shaded region A, B, C, D, E in the diagram is 12 square meters. So what area? This is the area. Oh, that's not what we wanted to do. Let's get some highlighter. And this is the area, isn't it? That's the one that they are saying. So they are telling us that this area is 12 square meters. Now, in your exam question, when they are giving you an answer, like here, they are not telling you to calculate the area. They are telling you, they are giving you an answer. That means we're going to solve this question by asking ourselves, well, how did they got that answer? How did they done that calculation? So use your answer to part BC1, so that's the answer. Otherwise, and work out the value of y. So again, how did they got that 12? How did they got that area? Well, the area is irregular, right? So let's just, can we get that? Yeah, we can. Like what I mean irregular, well, it's not really irregular, but what I mean for us, if we don't have, I don't have a formula for this type of shape. I don't have. If I don't have, it's irregular, okay? So usually when you have an area or a volume to calculate of, let's call that irregular shape, because since we don't have an formula for that, it's irregular. How do we do that? We take the area or volume, depending on what question we want, of big regular shape, the one we do have the formula for. And from that, we take away the area or volume, depending, like I'm saying, what the question, of small regular shape. What do I mean by that? What's the big regular shape? What's the shape that I can calculate? It's the big triangle, isn't it? So if from the big triangle, I take away small triangles. So small triangle by 2, because there is 2 of them, they're exactly the same. Therefore, I will be left with that irregular shape, isn't it? So that's how we saw, and that typical not only in your junior cert, but as well in your leaving cert. That idea will not leave, you will only expand. So then the next question I'm asking myself, how do I calculate an area of a triangle? Well, we go to the table and we look for the formula. So when it comes to triangle, we have 3 different formulas, page 9. Which one do we choose? The one we have information for. Okay, so let's consider the one we know the most, which is a half multiplied by a, the base multiplied by a height. Okay, so if I'm looking at the big triangle here, so what is the height? So this will be the height. This will be the base. So that's fine. That will be a half multiplied by the base, which I know is 14, multiplied by a height, which is y. Perfect. Minus. Then 2 multiply. What about this small triangle? When it comes to a right angle triangle, one of them can become height, and then the other one can become base. So what do I know about this part? We've done the calculation. That part is 3, and that was the reason they are saying, you know what? That's what we've done in previous part. That's why they are saying part C1. We have an expression for x. Okay. So 2 multiply by, a half of a base, which is 3, multiply by a height. So instead of x, we're going to use our expression for xy. Now let's say I put x. So we know that that area is 12 square meters. When you have an equation that have two letters, you can't solve it. So that's the reason why we've done the previous part, saying that x is equal actually 3y over 7, because I can take that value, equal sign tells me x, right, is the same, and I can replace that. So that means we're going to have a half multiplied by 14 multiplied by y minus 2 multiplied by a half multiplied by a 3 multiplied by 3y over 7 equal 12. Now you are looking at it and saying, Jesus, that's very difficult to do. Actually, it's not. Let me show you. It only looks difficult. What you have on top of the fraction, always letter, can be written beside the fraction. So instead of having 3 multiplied by 7, we can write 3, 7, and then we can write y beside it. I am not changing value of this fraction. I'm just expressing it in slightly different matter so that I can see things a little bit better. So what I have here, I have a number that is beside y, and then I have all these numbers that are beside y. They are all multiplied. So what I can do, I can put that in my calculator, press equal, and I get that that is 7y minus, and all of these numbers, put them in the calculator, press equal, and I'm going to get that that is 9 over 7y. And then let's not forget it's still equal 12. So what do we do next? Well, I want the value of y, isn't it? So that means this number and this number can be added together. So I put 7 minus 9 over 7 in my calculator, and I get that is 40 over 7y. Now on the other side, it's still equal 12. I want value of y, not y multiplied by a number. How do I get rid of multiplication? By dividing and dividing both sides of the equation. Why? Because 40 over 7 divided by 40 over 7 will be 1. 1 multiplied by y will be y. In my calculator, I put 12 divided by 40 over 7. I press equal, and I get that that is 2.1. That's how we work out that area.